A single-stage centrifugal pump is one of the simplest and most commonly used types of pumps in the world. From water supply systems to industrial processes, it's the go-to choice for moving fluids with moderate pressure and high flow requirements. What makes it so popular is its compact design, ease of operation, and low maintenance compared to more complex multi-stage systems. So, what exactly is a single-stage centrifugal pump? It's a pump that uses a single rotating impeller to transfer fluid. When the impeller spins, usually powered by an electric motor, it throws the fluid outward from the center toward the outer edge of the pump casing. As the fluid gains velocity, the casing, which is often a spiral shape called a volute, gradually slows the fluid down and converts that velocity into pressure. This pressure then pushes the fluid out through the discharge port and into the pipeline system. The process is continuous and smooth, making it ideal for many applications that require steady flow. The single-stage design means that all the pressure is developed in one go, with just one impeller. This makes it efficient for low to medium head applications, such as irrigation, HVAC systems, booster systems, water circulation in buildings, cooling towers, and industrial transfer processes. It's not suitable for very high-pressure systems. That's where multi-stage pumps come in, but for 80% of industrial and commercial needs, a single-stage centrifugal pump does the job perfectly. Now let's take a closer look at the main parts of a single-stage centrifugal pump. The most important component is the impeller. It's the spinning element that transfers energy to the fluid. Impellers come in different designs like open, semi-open, and closed, depending on the type of fluid and the required performance. The impeller is mounted on a shaft, which is supported by bearings on either side. The shaft is connected to a motor via a coupling, usually a flexible or gear-type coupling that can absorb slight misalignments. Surrounding the impeller is the pump casing. This is typically made of cast iron, stainless steel, or other materials compatible with the fluid. The casing guides the fluid from the impeller into the discharge pipe while converting its velocity into usable pressure. On one side of the casing is the suction port, where the fluid enters. On the other side is the discharge port, where the fluid exits under pressure. To prevent leakage where the shaft passes through the casing, there is a sealing arrangement, usually a mechanical seal or a packed stuffing box. These seals are housed in an area called the stuffing box or seal chamber. Between the impeller and the casing, you may also find wear rings. These are replaceable rings designed to reduce leakage and protect the impeller and casing from rubbing against each other. Bearings support the shaft and reduce friction during rotation. Proper lubrication of bearings is essential to prevent overheating and mechanical failure. Now, even though the single-stage centrifugal pump is simple, problems can still occur. If the pump fails to deliver fluid even after proper priming, one of the first things to check is the direction of rotation. If the impeller is rotating in the wrong direction, which sometimes happens after wiring changes or maintenance, the pump won't develop pressure. This is easy to fix by reversing the motor wiring. If the direction is correct but there's still no flow, the suction line might be blocked or the suction valve could be closed. Sometimes the impeller is damaged, broken vanes or erosion can prevent it from moving fluid effectively. In such cases, the pump must be disassembled to inspect the impeller. If it's worn or broken, it needs to be replaced. Another issue is when the pump delivers less pressure or flow than expected. This could be due to worn wear rings or internal leakage between the high-pressure and low-pressure sides. Over time, the gap between the impeller and the casing increases, allowing fluid to recirculate inside the pump instead of exiting through the discharge. This not only reduces efficiency but can also cause overheating. Again, the only solution here is to disassemble the pump and check clearances. If they exceed recommended limits, the wear rings should be replaced. Vibration and noise are other signs of internal trouble. These can be caused by imbalance in the impeller, misalignment between the pump and motor, or worn bearings. A noisy bearing often indicates a lack of lubrication or contamination. If bearings are rough or noisy when spun by hand, they should be replaced. Cavitation is another common issue, especially when the suction conditions are not ideal. It happens when the pressure at the suction side falls below the vapor pressure of the fluid, causing bubbles to form and collapse violently inside the pump. This leads to pitting damage on the impeller and a distinctive rattling noise. To fix cavitation, improve the suction conditions, raise the fluid level, reduce the suction lift, or increase the diameter of the suction pipe to reduce friction losses. Mechanical seals are another wear item. They keep the fluid from leaking out along the shaft, but they wear over time due to pressure, temperature, and friction. If you see fluid dripping from the seal area, it's time to inspect or replace the seal. Sometimes improper installation or dry running causes the seal faces to burn, leading to premature failure. Let's now talk about the disassembly and maintenance of a single-stage centrifugal pump. Before starting any maintenance, isolate the pump, close the suction and discharge valves, lock out the power, and drain the pump casing. Remove the coupling guard and disconnect the coupling. Carefully take off the upper casing or volute cover, depending on the design. You'll now see the impeller. Loosen the impeller nut or retaining device. In some designs, the impeller is threaded onto the shaft, in others, it's keyed. Remove the impeller carefully to avoid damage. Inspect the impeller vanes for cracks, erosion, or signs of cavitation. If the impeller is badly worn, replace it. Next, check the wear rings if installed. Measure the clearance between the impeller and the casing or wear rings. If it's beyond the recommended value, install new rings. This is a key step in restoring pump efficiency. Inspect the shaft for straightness and any scoring. If the shaft is bent or worn, it will cause seal leakage and premature bearing failure. Now examine the mechanical seal or packing. Remove the seal and inspect the faces. If they are scratched, burnt, or worn, install a new seal. For packed stuffing boxes, remove the old packing and install new rings, making sure the joints are staggered. Lubricate them as per manufacturer guidelines. Check the bearings for wear, noise, or roughness. Bearings should rotate smoothly without any grinding or resistance. Replace any that show signs of damage. Clean the bearing housing and refill with fresh grease or oil, depending on the lubrication system. Once all parts have been cleaned, inspected, and replaced as needed, reassemble the pump in the reverse order. Use new gaskets and seals to ensure leak-free operation. Reconnect the coupling and align the motor and pump shafts using dial indicators or laser alignment tools. Misalignment is a leading cause of vibration and bearing wear, so this step must be done carefully. After assembly, fill the pump with fluid and prime it. Open the suction and discharge valves, and then start the motor. Monitor the pump during startup for noise, vibration, pressure, and temperature. Check for leaks around the seal or casing. A properly maintained single-stage centrifugal pump should run smoothly and quietly, delivering full flow at the expected pressure. For ongoing maintenance, create a routine schedule. Daily checks should include looking for leakage, unusual sounds, or pressure fluctuations. Weekly tasks might include checking oil levels and coupling alignment. Monthly, clean strainers and inspect seals. Annually, or during scheduled shutdowns, plan for a full inspection and replacement of wear components. When handled properly, a single-stage centrifugal pump can last for many years with minimal issues. Its simple design, reliable performance, and easy maintenance make it a valuable part of any fluid system, whether it's in a factory, a building, or a field.